Hi. This video we're gonna talking about introduce photoresistor, and we're going to integrate photoresistor in your circuit and read out its brightness using analog read. Okay, so photoresistor it means when it's light dependent resistor, and it's light sensitive. Normally, if it is in the dark, then the resistor is high, and when it's exposed to light, when it's bright, then the resistance drops dramatically. So, in other words, the resistance increases when it's getting dark, right? So we're going to build this circuit. We have 10 kilo ohms of resistor, and we have photoresistor that connected by series to 5 volts. And in between this photoresistor and 10 kilo ohms, we're going to have this analog input. Okay, so this analog input, like we talked about in the previous video about digital and analog, and this is going to be the input that's going read from 0 to 1053. Okay, when you have 1053, which means it's going to be equal to 5 volts here. The voltage drop here is 5 volts. And if you read at 0, which means the voltage here is going to be 0. Okay, so knowing that, we're going to go ahead and create this circuit in ThinkerCAD. Again, in the previous video, if you have read out analog input, then you can use the equation to figure out basically the voltage drop across this 10 kilo ohms. And again, you can further on to figure out the voltage drop across photoresistor. So now let's go for it. We're going to go to this ThinkerCAD. So I already dropped Arduino and a breadboard, and also a resistor in here, and this resistor is 10 kilo ohms. And what we have over here is going to be a photoresistor. Okay, so what we're going to do is we're going to build that circuit, this particular circuit right here. Okay, so it's connected to the analog 2. So what we're going to do, we're going to start with 5 volts, and this 5 volts is going to directly go to this photoresistor, right? It's right here. Okay, and then this photoresistor going through this resistor 10 kilo ohms, and this 10 kilo ohms is gonna come back to our ground, so you can go back to the ground right here. So this is our circuit, but remember, we're gonna have an analog input that is between this photoresistor and resistor, so it's anywhere along this row 7, right? So I'm going to start on here. That's in between them, and we're going to go to the analog, and our analog is at the bottom, so I can go around here. So that's our analog 2. So that's our circuit. Then we're going to go to our code. So I already have the code ready here. Let's go ahead and interpret them. So integer, I give a name for this variable. It's called just value, val equal to 0. Okay, so that's the initial value. Then in the setup, we have serial.begin 9600. That prompts us we're going to use the serial monitor right here. Then inside the loop, we'll give a definition for this value. Initial at 0, but what's the true value? Definition of this VAL. It's going to be analog, this read at this point, analog 2. Okay, again, this is going to be any value between 0 to 1023. Okay, so we're going to read it out. So then here's a serial print line, a different line of this value. So we start our simulation and let's see what we have. I needed to take out the serial monitor. So you start to see this is value changes, right? It's 54. Now we're going to click on this. I like this. You can change the darkness and bright from dark to bright, right? So we did that. So you notice when you drag this brightness bar, the number changes correspondingly. Now let's think about the rationality behind. When we talk about photoresistor, when it's getting darker, then what happens? The resistor go up. The resistance in the photoresistor go up. Then thinking about this circuit, if this have more resistance, this is gonna take out more voltage, right? If this take out more voltage, it's basically divided 5 volts between this photoresistor and 10 kilo ohms. When it's getting darker, photoresistor have more resistance. It's gonna take up way more voltage. If this take up way more, the resistance across this 10 kilo ohms is gonna be less. And that's basically measured by this analog input. All right, so ideally, what we're gonna see is when it's getting darker, this value, analog value, should decrease, which is right on track. It's getting darker. This across the voltage across this 10 kilo ohms, it's gonna get less and less. Right? We can get back to even 54. And when it gets brighter, it's gonna be opposite scenario. This number again gets higher. Okay, and again, you can use the video we did last time. For example, the analog right now is 959. You can use this value and put into the equation to figure out the voltage across this 10 kilo ohms and also the voltage across this photoresistor. You can refer to the previous video on Arduino about voltage divider with the photoresistor. That's all for this one. Hopefully you had fun, and I'll see you next time. Bye.